Hey everyone, and in this video we are going to talk about the Arduino. And Arduino is one of the microcontrollers that we use to sense something and also actuate something. So microcontrollers are basically the brain of your mechatronics device. So it reads some readings from a sensor, and then it processes that, and it creates some control, and then it generates the output that is following your control, and that goes out to your actuator. And then based on how your device moves, and then you're going to sense it back, and then you're going to maybe control, and then it is going to be in a loop like that. So everything that is being done within this box is what a microcontroller does. And nowadays, one of the two very popular microcontrollers that are used by either hobbyists or in industry as well, in academia, are Arduino and Raspberry Pi. And Arduino is basically a very simple controller that has multiple input nodes that can read signal and a couple output nodes that can generate signal. And here is a USB connector that is being connected to a PC. So this is just a controller, it's not a PC. For interface between human, you generally use a PC, and then through that PC, that information is being embedded into this controller. And after you embed everything here, this thing works by itself, a standalone thing. On the other hand, this guy, Raspberry Pi, is a slightly advanced version of this Arduino. This is actually a small PC, I would say. So it has an OS in there. It's a Linux, and it has more ports here and there, and generally has a better computation and power, and also better memory, etc., but also a little bit more expensive and consumes more power. So if you are doing something more simple, generally Arduino is the go-to thing, but Raspberry Pi is also a good one to pick. And in this course, we're going to focus on this Arduino, okay? And this is actually, if we were using a PC to create a code and embed that into Arduino, this is the screen that we are going to use, and you code in some information, and then that is going to bake that code into this Arduino chip, and it just has that information in there forever. Well, about the coding part, I'm going to deal with that a little bit more detail in another video. That is going to be the introduction to TINKERCAD. But like I mentioned, this thing can read some readings from the sensors, and it can generate some signals. And first, let's focus on generating the output from an Arduino. So once you have this code from your PC, and then you embed that into Arduino, then Arduino is going to have this logic inside it. And what this does is it uses pin number 7 to generate an output. So this pin number 7 is going to generate some voltage, and you would like to have an LED connected and a resistor, and that goes back to the ground. So you have a circuit formed like this, okay? And this pin is actually something, well, let's kill this thing very small and make this thing larger. Okay, so what I'm drawing is there's a rail of these pinholes, right? So these I can see there it's from 0 up to 13, and there's a ground, and there's a 5 volt, etc. And here are some others, some used for digital signals. So anyway, this is the input and output nodes that I just drew down here, okay? So again, if you have your wire connected from pin number 7, and then that goes to one of the legs of an LED, the positive one, and the negative one is being connected to the ground through a resistor, then by embedding this code into Arduino, this LED is going to blink for 1 second, and one thing to note that is LED has polarities. So the long leg is the cathode, and that one should be connected to the signal. So for example, here, that one should be connected to the signal, and the short one, the anode, that one needs to be connected to the ground. And the reason why we have a resistor here, resistor generally, this one should be for 70 ohms, and that one is to burn some current so that the current is being limited by this resistor and we don't burn this LED down. Okay, so that's the reason why we have a resistor here. And by the way, all the inputs and the output voltage that is generated by these pins are 5 volt. Okay, so this part is about how some output is generated by Arduino. So there's a 5 volt output coming out for 1 second, and then it stops for 1 second, and then again 5 volt coming out. So this one turns on and off and on and off, etc. And next, let's take a look at how to read some signal into Arduino. And in this case, we would like to use a switch so that you can read whether you have pushed a switch or not, or something like that. So this is a very typical push button, and it generally has 4 legs like this, and let's call those A, B, and C, D. And inside this push button, A and C are connected, and B and D are connected. And by pressing this down, these two gets connected. So if I draw that right hand side here, so A and C are connected internally, B and D are connected internally. So by pressing this down, this thing is closing, so these all 4 nodes are going to be all connected. That's how this push button works. And when you apply this into the breadboard, well, this black grid line, these are the breadboards, and when you connect this, you connect between the two, how should we call this, 2 parts of the breadboard, just like you did for the IC chips, the op-amp. Okay, so between these 2 area, you hook these 4 legs in there, and then depending on whether you push it or not, it's going to be connecting and be disconnected. So here and there, this row and that row should be used for this push button. You don't want to use this row and that row and expect this push button to function, because if you have your LED or whatever other circuit connected like that, then regardless of whether you press this down or not, this thing is connected always. So this switch or the button is kind of useless, right? So you want to form a circuit such that you have your thing connected like that. So if you have a configuration like this, you see by pressing this down, this thing is being interconnected, so the circuit is closed. But if you just leave it open, then you see they are disconnected. So your LED or whatever circuit is going to be not closed, it's going to be open. Okay, and by the way, generating an output and reading an input is a totally different one. So you don't want to get confused between these two. Okay, so this part is just showing how you generate an output from a pin, and from here we would like to see how you read an input from a switch. Okay, so if we move on to next page, this part is just a slightly different part, and we have that rail, same one as well. And this is how you would like to configure your circuit. For example, the red one is just simply copied from the left, and this blue lines are for reading your input. Okay, so let me just erase this just to make sure we don't get confused. And by the way, this note is going to be shared on Folio, so don't worry. So, like I said, A and C are going to be interconnected, and D and B are going to be interconnected. So you would like to have your circuit connected something like this, whatever circuit you have. Okay, that way if you press this down, your circuit is going to be closed. If you leave it, your circuit is going to be open, disconnected. Okay, and this here kind of shows this part. Okay, and so let's see why we would like to have a circuit like this. So when you press this button down, that means this and here and there are going to be interconnected like this, you see? So we have a closed circuit like that. One more time. We see that if we press this down, then from here to there, they are going to be connected. So we have a circuit that is closed like this through, and that is highlighted by the yellow color, right? So if you press this button down, then to pin number 5, 5-volt flows into it. So your number 5 is reading 5-volt. However, when this is not pressed, then that means here and there are disconnected. So 5-volt is not being connected to this guy anymore, right? So this part is just in the air. So this wire is just in the air. It's not connected to anything. And you see pin number 5 is connected to the ground. And so if you don't press the push button, number 5 is reading just 0 volt or the ground. And this is something called a rundown resistor. And the reason why we have this thing is we would like to have 5 volt flowing into pin number 5, not going to ground. Let's take a look here. So say you have pushed this thing down, and now this thing is being connected like this, you see? So 5 volt is up to this point. And if we didn't have that resistor and this is just connected like that, then your 5 volt is going to be confused. Do I have to go this way or that way, right? But if we had that resistor here, then 5 volt thinks, oh, this is bumpy, I don't want to go this way. All the voltage is going to be connected to pin number 5. So that's the reason why we have this resistor here, and you can have something like 1 kilo ohm or like that. Okay, so this circuit is how you read a signal coming from a switch to pin number 5. And this circuit here is that how to generate 5 volt coming out of your pin number 7, and that is lighting up this LED. Okay, so what we just talked about so far is about how we create these circuits so that we can turn on the lights or off, or you can press the button down to provide some input to the Arduino. And in the other video that I just mentioned, in the introduction to TINKERCAD, we will a little bit more focus on the coding part to explain how this coding thing works. Okay.